Welcome to the deep dive. Today we're looking at some truly incredible natural sculptures.
We are indeed. Think about the sheer power of things like wind, rain, water, just working away for millions, even hundreds of millions of years.
Yeah, it's wild. These forces have basically carved up our planet, creating these, well, frankly, bizarre and beautiful rock formations.
Absolutely. And we've gathered info on 10 of the rarest, most fascinating ones out there.
Right, so our mission today is kind of a deep dive into what makes these formations so unique, so different.
Forget your standard mountains and valleys. We're talking about rocks that look like trees, rocks covered in gold, arches that seem impossibly delicate.
Rocks that seem to defy gravity altogether.
Hmm.
So let's jump right in. Where are we starting?
Let's begin in Bolivia with a formation called the stone tree, or Arbol de Piedra.
The stone tree. Okay. Sounds descriptive. It's what, about 7 meters tall?
That's right, 7 meters. And it really does look remarkably like a tree, hence the name. It's a designated natural monument there.
So how does a rock end up looking like a tree? Is it like wind?
Exactly. It's almost entirely down to wind erosion. Imagine sand particles carried by strong winds constantly blasting against this rock face.
Like natural sandblasting?
Precisely. And this has been happening for possibly over 1 million years.
A million years of wind and sand. Wow.
It just wears away the softer parts of the rock more quickly, leaving behind this more resistant tree-like shape. It really highlights how variations in the rock itself, plus the wind patterns, create these specific forms.
That's incredible patience from nature.
Yeah.
Okay, from a stone tree to a golden rock. This one's in Myanmar.
Yes, the Golden Rock, or Kaiktio Pagoda. This one is visually stunning
Yeah,
and quite intriguing.
tell me about it. It's perched on a cliff, right? Pretty high up.
Very high up, about 1,100 meters of sea level. And it's this huge granitic boulder, maybe 5 meters tall.
Granite, so pretty solid stuff.
Oh yeah, very hard rock. But what's really striking is first, there's a small pagoda built right on top of it.
Okay.
And second, the entire boulder seems to glow gold.
Wait, the rock itself is gold?
No, not naturally. That golden sheen comes from centuries of pilgrims visiting the site.
Pilgrims, what do they do?
They affix gold leaves to the rock as a sign of devotion. So over many, many years, it's become completely covered.
That's amazing. A natural wonder transformed by faith.
It really is. And the other thing is how it looks like it's balanced right on the edge, got to tumble down.
Yeah, I've seen pictures. It looks like it defies physics.
It does. It's quite unsettling in a way.
Mm.
And there's a legend tied to that precarious balance.
Oh, do tell?
Well, the local belief is that the rock rests on a single strand of the Buddha's hair.
Wow, really? A strand of hair?
That's the legend. It gives the site immense spiritual significance, naturally. It's said that if you visit 3 times in 1 year, it brings wealth and recognition of your good deeds.
A blend of geology and deep-seated belief.
Yeah.
Fascinating. Okay, let's travel across the globe now to the USA.
Correct. To Arches National Park in Utah, home of perhaps the most famous natural arch in the world, Delicate Arch.
Oh yeah, everyone knows Delicate Arch. It's like the symbol of Utah, isn't it?
It absolutely is. It stands about 6 meters high, and it's just this incredibly elegant, freestanding structure.
So how did that form? Was it water this time or wind again?
It's a combination, mainly acting on sandstone. It started as what geologists call a fin, basically a tall, thin wall of sandstone.
Okay, like a big rocky fence.
Sort of, yeah. Then, over vast amounts of time, water seeped into cracks in the sandstone.
Mm-hmm.
In winter, that water freezes, expands, and pries the cracks wider. It's called frost wedging.
Right, like ice breaking up pavement.
Exactly that principle. Wind also helps, carrying away the loosened sand grains. Bit by bit, the fin gets hollowed out.
Until eventually, you're left with just the arch.
Precisely. The more resistant parts remain, forming that delicate shape. Sandstone, being compressed sand, is susceptible to this over geological time.
It's amazing how much material must have been removed. It looks so fragile.
That's the allure, isn't it? They seem temporary, yet they've withstood so much for so long.
Definitely. Okay, next up, we're heading to Egypt. Mushroom rocks.
Yes, the mushroom rocks found in Egypt's White Desert, for example. The name is pretty self-explanatory.
I can picture it. Rocks shaped like, well, mushrooms. How does that happen?
It's a classic case of what's called differential weathering.
Differential, meaning different rates.
Exactly. You have layers of rock with different hardness. The softer rock erodes much faster than the harder rock.
Okay.
So imagine a layer of hard, resistant rock sitting on top of a layer of softer rock.
Like a cap.
Perfect analogy. That hard cap rock protects the softer rock directly beneath it from erosion, especially from wind abrasion.
Ah, so the wind wears away the softer stuff around the base faster.
leaving behind a thinner stem supporting the wider, harder cap. Result, a mushroom rock.
Nature's little umbrellas protecting the ground beneath. Got it.
It's a neat demonstration of how rock composition dictates the shape erosion creates.
Very cool. All right, sticking with deserts, but back to the U.S. Arizona this time.
The wave.
Ah, the wave. This one is visually spectacular, truly unique. What's the story here? It looks like solidified waves, kind of psychedelic.
That's a good description. Essentially, these were ancient sand dunes,
Mm.
like massive dunes from millions of years ago.
Okay, dunes. But they're rock now.
Yes. Over time, they were buried, compressed, and minerals dissolved in groundwater cemented the sand grains together, turning the dunes into solid sandstone.
So petrified sand dunes.
In essence, yes. Then, geological uplift exposed this hardened sandstone.
And then the wind and rain got to work again.
You got it. Rainwater runoff and wind erosion carved into the layers of this cross-bedded sandstone, accentuating those original dune shapes and creating the flowing wave-like patterns you see today. The colors, those reds and oranges, come from iron oxides.
It sounds incredible, capturing the shape of wind-blown sand and solid rock. Is it easy to get to?
Not particularly, no. Access is restricted to protect the fragile formations, and you need a permit, often one through a lottery. Plus, it involves a pretty challenging hike through the desert.
Right. Worth it for the pictures, though, I bet.
Definitely a photographer's dream, and popular with hikers who manage to get permits. It's about preserving something very special.
Makes sense. Okay, big journey now, down under. Ayers Rock, or Uluru.
Uluru, yes, a truly iconic monolith. It's much more than just a rock, though.
How so? I know it's huge and very red.
It is huge, one of the largest monoliths in the world, and yes, very red, especially at sunrise and sunset. But it's also a deeply sacred site for the local Aboriginal people, the Anigu.
Ah, right. A spiritual center.
Absolutely. It's a UNESCO World Heritage Site, listed for both its natural and cultural significance. It's been a place for ceremony and storytelling for tens of thousands of years.
That puts the timescale into perspective. How old is the rock itself?
Geologically, it's thought to have started forming around 600 million years ago.
600 million. That's hard to grasp.
It really is. It's composed mainly of arkose, a type of sandstone rich in feldspar, and its sheer size is staggering. It rises 348 meters above the surrounding plain.
And that changing color thing.
Yeah.
Is that real?
Oh, very real. It's famous for it. At dawn and dusk, the low-angle sunlight interacts with the iron oxide in the rock and the dust particles in the atmosphere, making Uluru appear to glow this incredibly vibrant red. It changes throughout the day, too, from ochre to brown to violet.
Like it's alive. Amazing.
Yeah.
Okay, still in Australia, but shifting west. The pinnacle.
Yes, the pinnacles. In Nambung National Park, Western Australia, a very different kind of landscape.
But I read they're sometimes compared to James Bond Island, that tall rock in Thailand.
There's a similarity in that they're limestone formations sticking up vertically, but unlike Kotapu, which is a single monolith, the pinnacles are thousands of limestone pillars rising out of yellow sand dunes.
Thousands. Wow. So limestone again, formed differently.
Yes, this limestone originated from seashells in an ancient marine environment, rich in calcium carbonate.
Okay, ancient seabed.
Right. These shells broke down, formed lime-rich sands, which were then, over time, lithified into limestone underground. Later, overlying sand layers were eroded away by wind and rain, exposing these harder limestone pillars.
And the sand around them is different.
Yeah, it's quartz sand. So you have these weathered limestone spires, some short and stout, others several meters tall, scattered across this sandy plain. It looks quite otherworldly.
A limestone forest in the desert. Okay, since it was mentioned, let's actually go to James Bond Island now. Koh Tapu, Thailand.
Koh Tapu it is, located in Phang Bay, which is famous for its emerald waters and dramatic limestone karsts.
Karsts, like limestone towers.
Exactly. And Koh Tapu is probably the most famous example. It's this striking limestone monolith, about 20 meters high, standing just offshore about 200 meters out.
And it got famous because of the Bond movie.
Absolutely. It featured in the 1974 film The Man with the Golden Gun and became instantly recognizable worldwide. People often call it James Bond Island.
It does look pretty dramatic, tall and thin, wider at the top than the bottom almost.
That distinctive shape is due to marine erosion. Limestone is soluble in slightly acidic water, and the wave action, particularly around the base at sea level, has eroded the lower part more rapidly than the upper part over millions of years.
Ah, so the sea's constantly nibbling away at its feet.
Precisely, leaving that iconic, almost top-heavy appearance. It's a classic example of coastal karst topography.
Incredible. Okay, next stop. New Zealand. And something called split apple rock.
Yes, split apple rock. This one's quite charming and very aptly named.
Does it actually look like a split apple?
It really does. It's a large granite rock formation located just off the coast in Abel Tasman National Park on the South Island. And it's perfectly split down the middle, like someone cleaved an apple in two.
Granite this time. That's much harder than limestone or sandstone.
Much harder, yes.
Ugh.
Which makes the clean split even more intriguing.
So how did it split? Any ideas?
The exact cause and timing aren't definitively known. One theory involves that frost wedging again, water getting into a pre-existing crack or joint in the granite, freezing and expanding over countless cycles, eventually forcing the rock apart.
Makes sense. Or maybe a jolt like an earthquake.
That's also possible. Or just the slow, inexorable power of weathering, exploiting a weakness in the rock over a very long time. Whatever the cause, the result is this wonderfully peculiar landmark.
It sounds almost comical. A giant granite apple sliced neatly. Is it a big tourist spot?
Oh, definitely. It's very popular with boat tours and kayakers in Abel Tasman. It's just one of those geological oddities that catches the eye and sparks curiosity.
I can see why. Okay, we've reached our final formation. We're heading to Canada.
To Quebec, yes, to see the magnificent Perce Rock, or Russia Perce.
Perce Rock, another arch.
Yes, and it's one of the largest natural arches located in water anywhere in the world. It's a huge tourist draw for the region.
How big are we talking?
It's a massive limestone formation.
Yeah.
About 88 meters high at one end and stretching for 433 meters in length. Quite imposing.
Limestone, again, so susceptible to water erosion.
Very much so. And interestingly, Perce Rock used to have two arches.
It did. What happened to the second one?
It collapsed. On June 17, 1845, the outer, smaller arch succumbed to the relentless action of the sea and crumbled.
Wow. A reminder that these things aren't permanent.
Exactly. Geology is dynamic. The reigning arch is still enormous, though, about 15 meters high. It's a truly spectacular sight, especially seen from the shore or a boat.
It sounds incredible. What a journey that was.
It really shows the sheer variety, doesn't it? From wind-carving trees in Bolivia to waves-shaping limestone towers in Thailand.
To gravity-defying boulders covered in gold leaf and that delicate sandstone arch in Utah.
Not to mention split granite apples and ancient dunes frozen in time.
It really hammers home the power of, well, simple things like wind and water acting over immense timescales.
Absolutely. These formations are monuments to time itself, sculpted by patient, relentless natural forces.
Yeah, it's humbling, really. Which brings us to a final thought, I suppose.
Go on.
When you think about the hundreds of millions of years involved in creating something like Uluru or Perce Rock, it kind of dwarfs our human perception of time, doesn't it?
Completely. Our entire history is just a blink in geological terms.
So it makes you wonder, what other incredible geological features are being slowly, silently sculpted right now? What hidden wonders are taking shape under the influence of wind and water that maybe won't be revealed for thousands or even millions of years?
That's a fascinating thought. Masterpieces in progress, hidden all around us.
Something to ponder. Well, thanks for taking this geological tour with us today.
My pleasure. Always amazing to explore Earth's artistry.